This lesson, we are looking into capture-recapture. So capture-recapture is like your mom capture you to ask you to do some housework for her. You can't say no, of course, because it's mom. And then when you thought like, okay, I finished the housework, now I can have some free time. And then she asks you a question, have you done your revision? And that's the moment when you got recaptured again. And that's also the moment when you have a similar face, I got caught again. Just kidding. Capture-recapture is a method that is very useful to estimate population size when the overall population is unknown. A very famous classical example would be like a sea. There's a sea or pond of fish where it's not possible to count every single one of them. Because if you want to count single one of them, there's only one way, which is to fish them all and count them one by one. But again, that will be quite inhumane. It will be impossible, no? So because if you have to count them, you have to kill them first. By the time you fish them up and put on a bucket and count them, unfortunately, they would make some really nice dinner because they'll be dead. Anyway, we can learn a formula to work out capture-recapture, and we also need to recognize the assumptions and limitations of the capture-recapture method. Usually, sometimes there's a one-mark question at the end of the question. Right, so this is a statistical method to use to estimate the size of a population when a direct counting is impractical or impossible. You can't count all the fish in a sea or in a pond. It's impossible. So the key processes are usually step 1, you're going to initial capture some of them and you're going to put a mark on them. Now we call this number C. Okay? And then you let them go, and the next day or
24 hours later,
you recapture them again. We call this the value of R. And then you could check the number of the recapture population and see how many of them are marked. That number is called M, and using these three values, we can estimate total population P. Essentially, your teacher might have taught you this ratio. It's essentially a ratio, but we can just formulate it into a formula which you can use. So P equals C times R divided by M. C is the initial capture, R is the amount that you recaptured second time, and M is how many that has been marked when you recapture the second time. All right. So what's the assumption is? The assumption is, well, it's a closed population. In a pond, you assume there's no fish that can leave or enter the gate on the pond. So then there's no secret hidden way that fish can escape. Then you assume the number is going to be staying the same, or the fish is not lay new eggs, fish eggs, to get to new births, or there's no dying fish. Because when the fish die, the number go down, yet you never know, right? So we assume that it's a closed population. Or a second assumption is that the marks on the fish are not lost. So when you capture the first time, you put a mark on it, you assume the mark is going to stay on the fish forever. Because when you take a second time, if the mark is gone, where the fish was marked, so the number was wrong when you count it. So you assume the mark is not lost. Example, any One Piece fans in here? I'm calling them out. I love One Piece myself. Luffy wants to estimate the numbers of fish in a lake. He catches 50 fish, places a tag on them, and releases them to a lake. The next day, he catches 300 fish from the same lake. Of these fish, 10 are marked. Estimate total number of fish in the lake. So they want you to work out total number. So total number in the formula, P equals C times R divided by M. That's the P value we want to work out. So your task is to find, to match which number is which variable. So initial capture is C, so that will be C. C is 50. And then recapture 300 of them, so that will be recapture, so it will be R, so R equals 300. And then M is marked, 10 of them is marked, so M equals 10. So P equals C times R divided by M. And then put in the calculator, or you just work it manually. So that's 15, 3 zeros divided by 10 divided by 0. So P equals 1,500. So there are 1,500 fish estimated in the lake. Okay, it's all estimation. In this example, a group of students had a large jar of jelly beans. They invited all students in the school to guess the number of jelly beans. The person who got the closest will win the whole jar. Now, one lunchtime, the jar was left unattended in front of Sneaky Peter. He decided to sneak to the jar and attempted to use the capture-recapture method to estimate total number. He thinks he's quite smart. Sneaky Peter took a handful of 20 jelly beans and licked all of them. Then he put them back in and then took another handful of 25 beans. He smelled all of the beans and only 2 had his scent. Oh, I can't help it. I would puke. Work out an estimate of number of beans in a jar. So once you know it's capture-recapture question, it's all about this formula, P equals C times R divided by M. So C is the initial amount that we capture, so C means capture. So he captured 20, so question A, P equals C is 20, he captured 20, and then recaptured 25, divided by marked. There are 2 of them marked by his scent. Ew. So work it out. 20 times 25 is 500. 500 divided by 2 is 250. So we guess there are 250 beans altogether in the jar. Part B. Guess the reason why Sneaky Peter didn't win the jar despite of his disgusting behavior. Well, the reason, of course, is because he got caught and someone found out it's quite disgusting behavior. That's not allowed. Head teacher, kick him out of the school. Just kidding. The reason that he couldn't win is because because the scent evaporated over time. So you can say part B because because the mark, we can say, so instead of using the word mark, you can use the word scent because that's what the mark means in here, or the tag. Here's the scent. Okay, evaporated over time. Evaporated over time. So in other words, the calculation is not correct. Okay, so that's the estimation. Or you can say he did not shake the jar evenly before picking the second time. Right, so if you put it on the top of the jar, whatever you got, it'll be, whatever you put in the beginning, it'll be probably somewhere still in the top of the jar rather than in the middle. So yeah. Here are 2 practice questions, question 1 and question 2. Okay, pause the video, have a go at them. Use the formula P equals capture times recapture over marked. And have a go at the question. When you're ready for the answer, press play. Here are the answers. Question 1, A is 50, B, no butterfly has died or newborn butterflies. So that means there's no in and out, the population is the same. Or you can say no mark is lost on the butterflies. So all the marks you put on there, it still remains in there. Question 2, the answer is 1,225. If you got it all correct, time to move on. Well done. Move on to the last question 3. But if you haven't got right, I'm going to go through question 1A and question 2, how to work it out. Okay, so Luke wants to estimate the number of butterflies in the greenhouse. He catches 15 and marks 15 of them and releases them. The next day, he returns and captures 30. 9 of these have been marked the next day. So he captures, so P equals captures is 15, recaptures 30, divided by marked 9. 15 times 30 is 450. 450 divided by 9 is 50. All right. Question 2. A French chef wants to estimate the number of snails in the field. Oh, escargot. So good. She captures a sample of 70 snails. So captures is 70. Puts them back, marks them, puts them back. The next morning, she catches another sample of 70. She finds 4 of them are marked. So 70 times 70 divided by 4 is 1225. All right. And that's the answer. The last practice question, this time is slightly trickier. See if you're able to work it out. Pause the video, have a go at the question. When you're ready for the answer, press play. Here's the final answer, 50. If you got it right, well done. Enjoy the maths joke. If you don't, let's go through how. So a farmer wants to work out the estimated number of sheep living in his pen. He captures some of them and puts a stem on each of them. A week later, he catches 60 sheep, and of these sheep, 15 are stemmed. So he catches 60. Now, that's a recapture, so R is 60. Now, that's not the first capture. So, therefore, C is not 60. It's the R is 60. And then 15 are marked, so M is 15. He estimated, he has the typo, he estimated, or he estimates there are 200 sheep altogether. So, altogether, that means P is 200. Now, using the formula, P equals C times R over M, we know P is 200. We don't know the value. Okay, we don't know how many sheep he captured at the beginning, so we don't know C, but we know R is 60 and M is 15. To work backwards, we have to times 15. So 200 times 15. So 200 times 15. If you're doing a shortcut about multiplying these numbers with zeros, you do 15 times 2, which is 30. 2 zeros, 2 zeros. So 3,000. So 3,000 equals C times 60. So to work backwards, you divide it by 60. So 3,000 divided by 60. The 0 can cancel out. 300 divided by 6 is 50. So C equals 50. And that's how you work it out. So to work backwards.